Good evening, students. Today I am going to deal with the topic that is angle between two planes, that is from the chapter 3D. So for that I have taken two planes. The pink marked one is plane 1 and the green marked one is plane 2. Consider this one, these are two planes. Then I have constructed n1 which is normal to plane 1 and n2 which is normal to plane 2. So if they are normal, this angle will be 90 degree and this angle will also be 90 degree. Let us say theta be the angle between plane 1 and plane 2. This I have taken between plane 1 and 2. Okay. Now if this angle is theta, now you look at this quadrilateral. In this quadrilateral you can easily see that sum of these two, this is 90 degree and this is 90 degree. Therefore angle 1 plus angle theta will also be equal to 180 degree. Similarly, look at this, this is 1 and this is 2, they are straight angle. Angle 1 plus angle 2 is also equal to 180 degree. So from the above two I can easily write angle 1 plus angle theta, it is equal to angle 1 plus angle 2, that they get cancelled both sides and I get theta, angle theta is also equal to angle 2. That means this angle between the two planes is also equal to angle between the normals. I can write here angle between two planes is also equal to angle between their normals. Okay, their normals. So when I want to find the angle between two planes, that means it will be enough to find their DRS. So suppose plane 1 has the equation a1x plus b1y plus c1z plus d1 equals to 0, and plane 2 has the equation, if I write like this, this is a2x plus b2y plus c2z plus d2 equals to 0. Therefore here angle between their planes, angle between two planes, it will be equal to cos inverse, since I am taking the normal, so here the DRS of normal, if I take, it will be equal to a1 b1 c1, and here the DRS will be a2 b2 and c2. So I can write the angle to be a1 a2 plus b1 b2 plus c1 c2 whole divided by square root of a1 square plus b1 square plus c1 square multiplied by square root of a2 square plus b2 square plus c2 square. Okay. So this is how we find the angle between two planes. For example, let me take one question. Suppose find the angle between the planes whose vector equations are this. Okay. So let me take this question. This is find the angle between the planes whose vector equations are r dot 2i plus 2j minus 3k. Okay. Question will be like this. Find the angle between two planes, that is r dot, first one is 2i plus 2j minus 3k equals to 5, 2i plus 2j minus 3k equals to 5, and second one is 3i minus 3j plus 5k equals to 3, 3i minus 3j plus 5k equals to 3, 3j plus 5k, this is r dot and it is equal to 3. So if I go on finding, first one is, this is my plane 1, I will convert it to Cartesian equation. In place of r dot I will put xi plus yj and zk. So the equation will be 2x plus 2i minus 3z equals to 5, and this is my plane 2 which has the equation 3x minus 3y plus 5z equals to 3. Here DRS of normal, I need that for the angle. This is 2, 2 minus 3, and this is 3 minus 3 and 5. So therefore angle between them is given by cos inverse formula, that is a1 a2 plus b1 b2, a1 b1 c1 are the DRS, plus c1 c2 divided by square root of a1 square plus a2 square plus a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So if I go on finding, it will be cos inverse. These three are my a1 a2, these three are a1 b1 c1, and this is a2 b2 c2. So I will be putting this. This will be 2 multiplied by 3 plus 2 multiplied by minus 3 plus minus 3 multiplied by 5 whole divided by square root of, this is 2 square plus 2 square plus minus 3 square. Again I will multiply square root of 3 square plus minus 3 square plus 5 square. So this will give you cos inverse. This is 6 minus 15 divided by square root of 17. Again 25 plus 9 34 plus 9 43. So this angle will be giving you cos inverse 6 getting cancelled, minus 15 divided by root under, this is 17 into 43. For acute angle we always take the modulus of that, so it will be cos inverse 15 divided by square root of this is 1, 5 carried, 731. So this is the final answer. This is all about angle between two planes, and the formula is given by this. So try to remember it as a formula. This will be cos inverse a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square. Okay. Now a similar kind of concept comes when I talk about angle between a line and a plane. Let us talk about that. Now look at this concept. Suppose I take a plane. Here I am taking a plane. This is suppose a plane. Let me darken it. Right. So this is my plane, the green surface, and this is a plane. Right. Now what I do is I draw a normal to it. Suppose this one is its normal vector. To find the normal, I take it this. Now I draw a straight line to it. Okay. Suppose I drew a straight line. Suppose this straight line is L1. Clear? Now if I draw this one and I take the angle between the plane and the straight line be theta. Okay. Now clearly you can see, suppose L1 I will give has the equation x1, I repeat, this is x minus x1 by a equals to y minus y1 by b equals to z minus z1 divided by c, and the plane has the equation ax plus by plus cz plus d equals to 0. Right. So here DRS of normal will be a, b, c. Now students, if this is theta, this angle will obviously be 90 minus theta. Now I have two lines L1 and N. right? So angle between your L1 and N, it is given by cos inverse, and this value is 90 minus theta. So if I want to find first cos theta, that is cos of the angle between them is 90 minus theta, because the angle between L1 and N is 90 minus theta. That is given by sum product of DRS, that is A into A plus B into B plus C into C, divided by square root of A square plus B square plus C square into square root of A square plus B square plus C square. You can easily see small a, small b and small c are related to the line, and capital A, capital B and capital C are related to the plane. So now I am interested in theta. So here I get sin theta, cos 90 minus theta, I can write sin theta. It is equal to A into A plus B into B plus C into C, divided by, we are getting here under root of A square plus B square plus C square into under root of A square plus B square plus C square. Okay. So using this formula I can easily find theta equals to sin inverse A into A plus B into B plus C into C whole divided by square root of A square plus B square plus C square into A square plus B square plus C square. So this is the formula for angle between the line and a plane. It is just similar to the angle between two planes, but here you can see we use sin inverse, and in the above formula you use cos inverse. So whenever question comes between angle between two planes, then you use cos inverse. Angle between the line and a plane, you use sin inverse. For example, I am just taking a question, find the angle between the line x minus 3 by 2 equals to y minus 3 by 1 equals to z minus 4 by minus 1, and the plane x plus y plus z minus 2 equals to 0. Okay. So now let us simplify this one. I have for line L1 has the equation x minus 3 by 2 equals to y minus 3 by 1 equals to z minus 4 divided by minus 1. Here the DRS, I am interested only in DRS, 2, 1 and minus 1, and here plane is given by the equation x plus y plus z minus 2 equals to 0. Therefore here DRS of normal is given by 1, 1, 1. Therefore I am interested in DRS only. Okay, this DRS and this DRS together I will take, and I will use the formula here, angle between, therefore angle between L1 and the plane is given by sin inverse theta equals to sin inverse, put it, this is A into A plus B into B plus C into C divided by square root of A square plus B square plus C square into square root of A square plus B square plus C square. Okay. So let us put it, this is sin inverse 2 into 1 plus 1 into 1 plus minus 1 into 1 whole divided by square root of, this is 2 square plus 1 square plus minus 1 square and square root of 1 square plus 1 square plus 1 square. So if I simplify this one, I will be getting sin inverse, this is 2 divided by root 6 and root 3, right? So this is sin inverse 2 divided by, this is 3 root 2, or I can write sin inverse root 2 divided by 3. That is the answer. Okay, this is the concept of angle between line and a plane, right? Now the last thing is distance of a point x1, y1 and z1 from a plane ax plus by plus cz plus d equals to 0, right? So the concept is very simple. Here you see, if I take a plane, suppose I take a plane, right? And here in this plane I have a point outside this plane. Okay, let us see. Suppose I take a point P which is having the coordinates x1, y1 and z1, and I want to find the perpendicular distance from P to this plane. Suppose PQ is the distance from P to the plane. Okay, let us denote it as D. So D will be just what you do, just copy and paste these points over here. In place of x you replace x1, in place of y you replace y1, in place of z you replace z1. So the formula will be ax1 plus by1 plus cz1 plus d divided by square root of a square plus b square plus c square. Okay, since it is distance, so I must take the modulus of that, right? So let me solve some questions on it. This type of questions will be, in the following cases determine whether the given lines are parallel or perpendicular and find the angle. This is question number 14. In the following cases find the distance of each of the given points from the corresponding given plane. Suppose I take 3 minus 2 1 and 2x minus y plus 2z plus 3 equals to 0. Okay, so let me take up one question. Find the distance of the point one, 2, 3 from the plane x minus 2y plus 3z plus 4 equals to 0. Okay, so very easy here. The given point is 1, 2, 3 and given plane is x minus 2y plus 3z plus 4 equals to 0. So therefore distance d is given by, you put these points and formula first you write down ax1 plus by1 plus cz1 plus d whole divided by square root of a square plus b square plus c square. Okay, so let us find it out. This is x. In place of x I will be writing 1, a is 1, so it will be 1 plus, this is minus 2 into, in place of y I will be writing 2 plus 3, in place of z I will be writing 3 divided by square root of, this is 1 square plus minus 2 square plus 3 square. I will take the modulus of that. So it is 1 minus 4 plus 9 divided by root under 14. So this is 6 divided by root under 14 units. Okay, so this is how we find the distance of the point from the given plane. So these are the topics which I wanted to discuss. I will be providing the notes in the group also. You make it and watch the video so that you can understand the concept properly and complete the exercise. Okay, so that's all for today. Thank you very much, students.